Hello and welcome to our lesson on separation techniques, evaporation and crystallisation. In our previous lessons, we started looking at ways we can separate different types of mixture. First of all, we looked at magnetism, using it to separate magnetic metals from non-magnetic substances. Then we looked at filtration as a method of separating insoluble solids from liquids. Insoluble means it will not dissolve. So in this example, you can see here we've got some what looks like muddy water. You can still see that you've got solid pieces in the liquid. They are insoluble because they will not dissolve. But you can also see from that brown colour there must be other substances which are soluble, so they have dissolved. It might be that your solution, your mixture of the dissolved solid and the solvent, the liquid, might look clear. Or if it looks a bit cloudy, it might be that your solution, your mixture, is saturated, so you've dissolved as much solid as you can in the liquid and there's no more that can be added. Or it might be that your solution, your mixture, might be coloured because your solid was coloured. So this is a good example of copper sulfate crystals being dissolved in water and the liquid turns blue. But there are no solid pieces because they have dissolved. These are soluble solids in a liquid or in a solvent. There are lots of words you need to be familiar with and be happy with that people often get muddled up with. So in this example here, I've got my soluble solid, which is the sugar. I've got my liquid, which is the water, and I have my mixture there, which is the sugar water. The solute added to the solvent, making a solution. You need to know those words. So often you'll see this word solution in an exam question or in something you're reading, copper sulfate solution. That means you have that mixture. The copper sulfate is dissolved in water. So why won't filtering work? Well, think about filtration previously. We had the solid stuck in the paper and the liquid went through. There is no solid here, it's dissolved, so it all goes through. So it was together and it is still together, so filtration won't work. So what's the way to separate a soluble solid from a solution? Well, it's evaporation. And evaporation is used to separate a solution of a solute, which is the dissolved solid, in a solvent, which is the liquid. Okay, I want to pick up this misconception with dissolving here. Dissolving does not mean that the solid disappears or the particles disappear. They're still there, they're just broken up and spread around in the water. So to your eyes, you cannot see them because they are now too small to see, but they're still there. And evaporation, well, why evaporation? Well, remember, evaporation is the change of state from liquid to gas. So that solvent, the liquid, if we can make that into a gas, it's going to change state, return into a gas. It's going to go up because gases do, and it's going to disappear into the atmosphere and leave our solid behind. Now, how do we do that? Well, remember that evaporation requires energy, heat or thermal energy to overcome those forces of attraction between particles. So we are going to need a heat source for evaporation to occur. Okay, so what kind of equipment might we need? Well, a beaker maybe, or a stirring rod, a heat-proof mat, a Bunsen burner, that's our heat source, wire gauze, a tripod, and an evaporating basin. And we're going to put our solution in the evaporating basin. The liquid is going to evaporate and the solids will not. So in previous lessons we talked about separation techniques. I have a mixture, they are together. I carry out a procedure and now they are apart. What is it about the technique I've chosen that causes them to now be apart? And that's the detail that we often miss. So where is the solid and the liquid in the beginning of evaporation? Well, it's in the evaporating basin, so they are together. Where are they at the end? Well, they have to be apart. So the solid remains in the evaporating basin and the liquid has evaporated out into the atmosphere. Why does that work? Because the liquid evaporates, but the solid doesn't. Again, they are keen on these scientific diagrams. It's not an art lesson. It's got to have labels in order to be a scientific diagram. Use a ruler if you've got one. If not, just try to be as neat as possible. And the lines must be touching the equipment they're labelling. And of course, use the correct names for the equipment. Most of us would remember most of those. The one that we tend to forget is the evaporating basin, not a dish, not a bowl, the evaporating basin. Evaporation can be quite a harsh process. You're applying quite a strong heat to this solution. The water will evaporate, but the crystals may not form properly, so you end up with a mush rather than well-formed crystals. The way around this is a process called crystallisation, and it's basically exactly the same as evaporation, but it's just a lower heat, so it takes a little bit longer, and so these crystals have more time to form well. You can use a water bath, and then so you heat it up gently, you take it off the heat, and you allow it to cool, and then it slowly allows that evaporation to happen. You might filter the crystals to get rid of any leftover liquid, and what you're ending up with then is these dry, pure crystals that are really well formed. So that's evaporation and crystallization, and that is the end of this lesson. Thanks very much, guys. See you next time.